Good evening, everyone. You are welcome to this lesson where we are talking about structural analysis and design. In our previous lessons, we were able to place our columns in the architectural design that was available, that was presented to us. Though this structure, we are not going to build it, it's just for the purpose of this lesson. In the previous one, also, we did structural analysis class 2. We did paneling. We paneled all the slab. Then we labeled all the beams. So if you want to know what I'm talking about, you can go back to the previous lessons where we talked about paneling. We talked about placement of columns in their strategic points. Today, what we're going to be doing is um, to prepare ourselves for the structural analysis and design, the calculations. So before every calculations, what you're supposed to do is to prepare a sheet, design where all your informations about the design will be. Without wasting our time, let's just go to um, the design information straight. The calculation sheets. Today we are going to be talking about what you're supposed to do before your structural analysis. In this sheet, we have all the information that is supposed to be contained in your design. Um, for instance, number one, we have project. What is the project? The name of the project, you put it there. The date, you put it there. The prepared by who? Your name. This is going to be prepared by you. So, if you are not a registered engineer, you cannot check it. So, you must employ the services of a structural engineer to check whatever you have designed and analyzed. So, if approved, the person will put the name here. Then the sheet number, if you prepare your sheet number, each numbers you name them. Then job reference if you have any. Then we now go to, this is the design information. Have to go to the client, the name of the client, the architect, the name of the architect that designed it, then the site where the building is located. The address should be there. The design engineer, you are still the design engineer. Then intended use of structure. This intended use of structure, we explain further whether the structure is for a residential purpose or a commercial purpose. If it is a residential purpose, a residential building has its own life load. A commercial structure has its own life load. So the purpose of which you are designing should be stated here. Like in this design, since we are going to be making use of lecture hall and offices, is a commercial is for a commercial use. You call it commercial commercial building. So that when the supervisor engineer comes to the site, he will know the reason or the purpose of the use of the structure. Then the relevant codes. Relevant codes, I use BS, that's BS 8110. You can call it 1997 or 1985, as the case may be. Anyone you wish to use out of them. Then design stresses. Concrete. For the design stresses now, we are going to be talking about design stresses. This is where we talk about the grade of concrete, characteristic strength of steel. In my own design, this design, I'm going to use the characteristic strength of concrete to be 20 Newton per millimeter square. So this was what I was explaining the other day. In this grade of concrete, this one will tell you that the concrete mix ratio is 1:1.5:3. The characteristic strength of steel is supposed to be 460. But in this country, characteristic strength of steel is not to 460, so I normally use 410. So exposure condition. mine is meant for all elements. Made for all elements. Concrete cover now. Talk about slab and stair 20 mm. Concrete cover here now is that space you give between the formwork and your reinforcement. That is the space between your formwork and your reinforcement is your concrete cover. So for the beam, I use 20 mm. Sorry, for the slab I use 20 mm. For the beam I use 25 mm. For the foundation I use 50 mm. These are the design information, so that when the structural engineer comes to site, the supervising engineer, they will check all these things. Then they will now go to the site and be, to state their observations. There's soil condition. From mine, in my area, the soil is firm. So the analysis that was taken some years ago, the geotechnical engineer, geotechnic engineer, they will visit your site, they will collect samples from different areas, they will now take them to the lab and analyze. So in our areas, or in our area, we have an average bearing capacity of 180 kilonewton per meter square. But when I want to design, I use 150 kilonewton per meter square. So it means that this structure, we are going to be using pad footing. The soil is strong enough to withstand the loadings of this structure. So the next one is the general loading condition. Yeah, in this particular structure, we are talking about life load. We are talking about commercial building. Life load here, we have a hall where everybody can enter and come out. So the critical life load there is 4.0 kilonewton per meter square. So people use 3.0 kilonewton per meter square. So I am using 4.0 kilonewton per meter square. Then the roof load and life load is taken as 1.5. This is a factored load. So when you are talking about life and death, it's 1.5 times 1.5. Then when we get there, we explain better. Then floor finishes is taken as 1.2. Floor finishes, that's the this is a dead load. Then wall and rendering is taken as 3.47. For only wall, 225 wall is 2.87. So rendering is 0.6 at both sides. So when you add 0.6 to 2.87, we have 3.47 kilonewton per meter square. Then we have our K. We have our K as 0.156. Then LA 11 arm, we have 0.5 plus 0.25 all square minus K over 0.9. This must be less than 0.95. If it is not less than 0.95, you come to this formula. K is equal to M over FCU BD square, where we have M as the moment, FCU as the characteristic strength of concrete, B is the depth of the concrete, then breadth of the concrete, which is always taken as 1 meter for a slab. Then D is your depth. This depth now, you will explain it later when we are designing. Then we said K must be less than KU. KU is 0.156, and we said you must get the value of K from this point. If this one is less than this one, you get your lever arm from this formula. All right. So then AS should be K FCU BD square over 0.95 FYZ. Fy is characteristic strength of steel. So after you must have gotten all these, you now move straight to your calculation sheets, where you prepare your calculation sheet like this. First, you have your member reference. Member reference, if you are working, if you are designing the slab, you put the slab here. So all the calculations, your member reference now, we talked about paneling. So any panel you are working on, you put the panel number here. Then your calculations will be shown here. Then your output. After designing everything, if it is 12 mm, you are to provide, and the spacing, you will state them here. So that is that for our lessons today. You like, follow, and share, so that in our next lessons we'll now go to calculations proper. Thank you, and God bless.